All right, we're going to continue on transformations of exponential and logarithmic functions. We are now up to example 5, and this is writing a transformed exponential function. So now we have to be able to write functions. Very important to be able to write functions. So you have to remember your rules, all the transformations, whether it's horizontal, vertical, if it's a reflection, if it's going to be a horizontal stretch or shrink or a vertical stretch or shrink. Those are things that you have to remember the rules for. All right, so if you do that, if you refer back to your notes and kind of look, then this should not be very difficult. All right, so let's get started. Let the graph of G be a reflection in the x-axis followed by a translation 4 units to the right of the graph of f of x equals 2 to the x power. Write a rule for G. All right, so the first thing we're going to do is say we've got G of x, and then we have a graph that's going to be reflected across the x and transformed 4 units to the right. So remember, when it's reflected across the x, that means it's going to be a negative in front of your f of x. So f of x is 2 to the x power. So if we're going to have a reflection, we're going to have a negative in front of that. So we're going to have negative 2, and then that's to the x power. All right, and then it's followed by a translation 4 units to the right. Remember, moving left or right is always going to be opposite the sign. So if we want to move it to the right, even though that's going in the positive direction, if you're thinking about a graph on the x-axis, moving to the right is going in the positive direction. But because a horizontal translation is always opposite h, that means it's going to be a negative. And when we're dealing with exponentials, the horizontal movement is always attached to the exponent. So we're going to have x, and then we're going to have minus 4. So x minus 4. And a good way to check this would be to graph it and see what does that look like. All right, so if we pull up our calculator, first, let's clear this out. All right, let's look at our window. Let's change our window a little bit. Let's go, our x's, negative 4 is probably fine. Let's go to our minimum and maximum. 4 and negative 4, that's probably good. All right, now we're going to graph f of x, which is our parent function. So that's 2 to the x power. So we're going to graph 2 raised to the x power. And then let's go ahead and graph g of x as well, because we want to see if we did the transformation right. So we got negative 2 raised 2. And then we're going to have x minus 4. And it would be fine to put that in parentheses as well. All right, so the blue line is going to be the original function, f of x, and the red line is the reflection across the x, translated 4 units. And you can see that that graph is your translation. So you can feel good about. And again, you can just choose a point and see if that looks right. But also, if you want to use your calculator, you can go to second table, and that gives you your table of values, and you can see if those are indeed both reflected and translated 4 units to the right. All right, last example, writing a transformed logarithmic function. Let the graph of g be a translation 2 units up, followed by a vertical stretch by a factor of 2 of the graph of f of x equals log base 1/3 of x. Write a rule for g. So the first thing we can see is that it's going to be translated 2 units up. Vertical translation is on the end. There's no parentheses. Remember that. And then followed by a vertical stretch by a factor of 2. So the vertical stretch is going to be 2 multiplied in front of the original function. And that's what we have to do to change this function. So we're going to say g of x. And we know we're going to have this in our function, but we're going to move this function up 2 and have a vertical stretch by a factor of 2. So again, a vertical stretch means that this number here, just as it is, goes in front of this function. And again, you can look at your rules if you want to see that. So let's go ahead and start with the 2 and then log base 1/3 of x. That does not change. And then how do we do a translation of 2 units up? So again, a horizontal translation is going to be in parentheses. Vertical translation is not in parentheses, and it goes exactly the way you expect it to. So up would be plus 2. So we just do plus 2. And again, if you want to use your calculator to graph those, you can do that. Kind of look at what you're dealing with. So let's hit clear, clear. And again, if you want to do log with a different base, this is only base 10. So to go 1/3, a base of 1/3, we're going to go to math. I always go up because I know it's the second one after I hit up. And then I'm going to hit enter. And that allows me to enter the 1/3. So you can enter any base if you use the log base button. And then I'm going to use x for the first function. And then let's graph the transformation as well. So we're going to have 2 base of 1/3 of x and then plus 3. So the parentheses are put automatically by the calculator, or sorry, plus 2. But we don't put the vertical movement inside the parentheses. It goes outside the parentheses. And if we want, again, we could change our window. You can see it pretty good here. It's not too bad. So we've got our h of x and our g of x. If you have any questions, please let me know.